Good morning, dear students. Today we will discuss descriptive analysis. Till now, in Unit 4, we have discussed how to make the questionnaire data usable, and now we'll be starting with the analysis. This is the most simplest form of data analysis, that is descriptive analysis. It just describes the data, and there are so many ways to describe data. We'll discuss it now. Descriptive analysis is the transformation of raw data into a form that will make them easy to understand and interpret, right? It is basically showing or presenting the data in a form that can be understood by anyone easily, right? Or you can say rearranging the data and then ordering them in one or the other way, then manipulating data to generate descriptive information. That is descriptive in itself, right? For example, we can have, we discussed four kind of scales: nominal, ordinal, interval, and ratio scales, right? So here is nominal scale. We can have two kind of things when it comes to nominal scales. For example, there's a racing, and you have got 10 horses, and you are going to judge them on the basis of few parameters, right? And these horses are just numbered 1 to 10, and that is a kind of nominal scale. Now coming to nominal scale, if you have got two categories in that particular scale, then either you can go with frequency table or proportion, that is percentages. For example, two categories can be male and female. If you have to divide something, if you have to judge something and compare it, like whether not comparison, but you have you if you want to check what are the perspectives from male point of view and from female point of view, then you can say that there are two categories of people, one is male and another one is female. Then you can go with frequency table generation or percentages. If you get more than two categories, for example, you have taken an example of age category. For example, you want to check whether perspective on one thing differs, whether what kind of the perspective different age group of people have. For example, you have got three categories, 3, 4, 5, any number more than two. One category is below 20, then 20 to 40, and then above 40. For example, you have got three categories of people, and now you want to check how many people says what kind of the criteria they have, the way they think as per their age. Then you can either go with the same thing, frequency table, or category proportions, that is again percentages, or mode. Mode here is a kind of a part of central tendency. Mode basically tells you how many times one particular number or anything repeats. For example, you want to see maximum, you want to see a number which is coming for the maximum times. That is basically called mode. When it comes to mean, median, mode, these are central tendency, and these define central tendency of any kind of the data. And mode is the simplest one. You have to just find out which number is coming at for the maximum number of times. So it is used in nominal data, because in mode we are not trying to say, you do not have to rearrange the data in case of mode. You have to just you will just have a look at the data and find out which number is coming, which number's frequency is the maximum. Whereas in case of mean and median, you have to arrange the data in one or the other way. Then type of measurement is ordinal. Ordinal means you have ranked the data. You have chosen preferences. You have chosen a product over the other. Then type of descriptive analysis over here would be either rank order, as the name suggests, ordinal, or the median. In median also you would be doing the same, almost the same thing like as in rank order. In median, what we do is we'll be arranging data either we'll be arranging data in one system either in increasing order or in decreasing order, and then we'll be taking the medium value, the value which is coming in the mid, or if two values are coming in the mid, then we'll be taking the average of those two values. So when it comes to ranking data, ordinal data, we'll be either going with rank order or median. Then interval data means it is still like ordinal one, it is still in rank, but the difference, the interval between the ranks is the same, right? So for that, when we know that this data is more comparable than ordinal, we'll be going with arithmetic mean. Arithmetic mean is when you have the similar differences in the values. For example, 2, 4, 6, 8, 10, these have the similar difference. 2 plus 2 4, then plus 2 6, then plus 2 8, then plus 2 10. This is a kind of arithmetic series, and you can easily go with arithmetic mean in this case. So when your data is such that 2 4 6 8 10 kind of arithmetic progression, then you can go with arithmetic mean. Last is ratio data, the data which is actually real, where zero also has some meaning. For example, you are trying to check somebody's height, somebody's weight, something like that, then we'll be having more options. Index numbers we can have, we can go with index numbers, geometric mean, harmonic mean, and so many other options would clear up when it comes to ratio kind of measurement, right? This is just about descriptive data. We are talking about describing the data right now. We'll be talking about other kind of analysis in another upcoming presentations. So here's a chart for you. Type of measurement, if it is nominal, and nominal, for nominal data, if only two categories are there, then you can go for frequency table or mode and proportion, right? If more than two categories are there, then you can either go with frequency table, mode, and category proportions. For kind of ordinal measurement, you can go with either rank order and median. For internal kind of measurement, then you can go with arithmetic mean. For ratio data, you can go with either index numbers, geometric mean, and harmonic mean. What do you mean by tabulation? This was one, till now we have just discussed what kind of data would suffice what kind of analysis, descriptive analysis, simplest form of analysis. Now if you want to tabulate the data, on the side of rows you will be mentioning something, at the time of columns you will be mentioning something, and you will be having a table which might tell you about the data in more detail, just after having a look at it, right? For example, you have data of 10,000 employees of a company, and you can't just see anything over there. But if you tabulate the whole data in form of their education, their performances and other things, then you will be able to read data more efficiently and more easily, and that too with limited time you have. So orderly arrangement of data in a table or other summary format. This tabulation basically is a kind of summary format. This can be divided in two parts: frequency table or percentages. Basically counting the number of different responses to a question and putting them in a frequency distribution is simple tabulation. And when you actually calculate the percentages also, we call them percentages, percent tabulation, right? So let us have an example, have a look at example. The arrangement of statistical data in a row and column format that exhibits the count of responses or observations for each category assigned to a variable. For example, do you shop at XYZ place? People would respond yes and no, right? Then you can actually calculate frequency of yes and no, like this. For example, you interviewed 450 people, 330 people said yes, and 120 people said no. This is just frequency table. If you make one more column here and you mention that 330 is this percentage and 120 is this percentage of total 450, then it would be percentages. Let us have a look here. Percentages means a part of whole expressed in hundreds. It makes data easier to interpret. For example, you will be, presenting the percentage of the whole population here, right? When you talk about the percentages, it is always easier to understand the depth of the data, and it's easy to talk about. For example, in 2000 population was this, and in 2000 it was this. So you can easily calculate the change, percentage change. Like it was decreased, it was increased, and it was increased by zero point 0.9, the percentage mentioned here, right? Central tendency, we already talked about this, but still when it comes to central tendency, it tells you the whole measurement of data, whether the data is normal or not. It would tell you so many things about the data, and this is the first step you have to go for while going for some other data analysis techniques as well, because you should know what kind of the data you have, what kind of the state, first of all, what kind of the scale you have used while collecting the data, whether it was nominal, just numbers, ordinal, ranking data, interval or ratio, that means ranking with similar intervals or actual numbers. Then measure of central tendency, mean, median, mode. Mean is basically a kind of arithmetic mean. You will be calculating averages. Then median means you will be arranging data in, one system, either increasing order or in decreasing order, and now you will be taking up the midmost value. If there are two values, then you will be calculating average of these two values. And mode is maximum occurring number, maximum occurring data, maximum occurring, the frequency of that particular number would be the maximum, that is called mode. Then this says how much your data is in the center, and measure of dispersion tells you how much your data is spread, right? For nominal data, there is no measure of dispersion available. Then for ordinal data, percentiles are available, and interval scale data, you can go with standard deviations. Percentile tells you, basically, it is a kind of, you are trying to give ranks to people in one or the other way, right? Ordinal means ranking data. Then median also tells you the ranks. You'll be taking up midmost value irrespective of what their average is. And percentile also says you will be sort of ranking the data. But here ranking would not be having similar intervals, again like ordinal scale. And standard deviation tells you how much your data deviates from the average, right? So it can be done only when your data is either in actual numbers or with similar intervals. Cross tabulation is a technique for organizing data by groups, categories, or classes, thus facilitating comparisons. Till now, we were just talking about data, describing the data. Now, if you go for comparisons, then you have to go with cross tabulation, a joint frequency distribution of observations on two or more sets of variables would be calculated here. We'll see it with the help of an example. Then contingency table, these are the results of a cross tabulation of two variables such as survey questions. Let's see how. For example, response to questionnaire on ethical behavior. Activity is like take supplies or miss deadline. People who are less than 50 years of, they replied this way. People who are more than 50 years of age, they says 26 out of them take supplies and 18 miss deadlines. Then men and women comparison, like men says 47 out of them says they take supplies on time and 3 did not report. Women says 33 are, you can say, ethical or take supplies on time, and 17 are not reported. Then when it comes to graduate people, or you can say in case of education, graduate or undergraduate, then this would be the comparison. Then in case of business executive or general people, this might be the comparison. So this way you will be comparing things so as to know how people behave, and it is a kind of complete comparison, how people behave, how there can be the difference between a graduate or graduate and undergraduate person, how can there be a difference between business executive and general public. Like this you can differentiate by just looking at the table. Contingency table can be like this: men, women, in total number, their yes and no about something, and then total number, right? We initially mentioned about a frequency table that was just for yes, no, and total. But here we are taking two parameters together, yes, no, and their gender. So that is contingency table. Cross tabulation basically is for analyzing the data by groups or categories, like we just mentioned in this example. Like with the help of categories we are trying to analyze the data, right? Then compare differences, or contingency table, we just have mentioned two variables together, or percentage cross tabulations. Yes, you can go with percentage cross tabulation as well. In the previous table we can mention one column extra for percentages. Let us see how. Like this: men, women, and their percentages of yes and no. Men, women, total percentage, and their yes no ka total percentage column wise, right? Base is the number of respondents or observations in a row or column used as a basis for computing percentages. Like in this previous example, we have assumed like total percentage. In case of percentage, total is always 100, right? Here 225 total people are there, and out of that some of them are men and some are women, right? So 225 is base value here. And when it comes to this kind of the percentage, I have assumed sorry, I have 330 people who are saying yes, so it would be a kind of base for all the people saying yes, and 120 people saying no, so it would be a base for all the people saying no. Like this, we have 450 people here, and they are also like 225 men and 225 women. That means when it comes to men saying yes or no, 225 would be the base. When it comes to women saying yes or no, 225 would be the base, because total women are 225. This the same way here also we'll be managing yes or no of women. Then elaboration and refinement. Elaboration is basically you will be trying to elaborate some data on basis of either one or two variables, or you can say you will be trying to or you can say the resolution of anything complex into its simplest elements, right? That is basically elaboration. And refinement also, it's like basically putting something in simplest form. So here is moderator variable. Moderator variable basically is a third variable that, when introduced into an analysis, alters or has a contingent effect on the relationship between an independent and dependent variable. This variable sometimes is unrecognized. That is why it creates problems. And it creates spurious relationship for the analysis. An apparent relationship between two variables that is not authentic. For example, in the previous example, we have mentioned men and women only, right? We might consider their marital status. For example, we mentioned that do you visit this particular place, or yes or no, right? Men and women, you are just trying to see whether they have visited the place or not. If you even if you check along with that whether they are married or not, this would tell you in much better way that how many women who are married are going to that particular place and who are unmarried are going to that particular place. That might give you one more angle, one different angle to the analysis, because sometimes places are maybe for married couples or maybe for unmarried more, right? So that also tells you so many things. That is why we take care of this moderator variable. This should always be checked before starting the analysis. Yes, quadrant analysis is very important. It can be applied to two rating scales or four quadrants, two-dimensional table, or for example, for performance analysis, right? Basically, when you go with performance analysis, generally we take with the help of we take the help of quadrant analysis. Like this, you can make the table of like using microwave oven, whether its importance is its performance rating. So many things can be judged like this by making a quadrant table. Then data transformation. Yes, when you have already editing encoding the data, after that also sometimes we face problems, right? For that, data conversion is the right technique. Then data conversion basically is changing the original form of data to a new format, more appropriate data analysis, and for generation of new variables, right? For example, we have used Likert scale in one example to ask people about their preferences, right? uh, for example, like this, uh, you might say collapsing 5-point scale like to 3-point scale. Why are we doing this? First of all, for example, there might be, you might be having very less questionnaires in your hand, and the data is such that you are not able to handle it with 5 rating scale, right? So you might convert that into 3-point scale. 5 to 3 is very easy. You will be clubbing these two pointers in one. You will be clubbing these two in one, and this is neutral, right? You can do it this way. For example, increased foreign investment in India poses threat to economic independence, right? 3% percent people says they strongly agree to this particular statement. 12% agree to the statement. 30% people are neutral about it. 45% people disagree to this particular statement, and 10% strongly disagree. So you will be converting this particular table in this. You will be collaborating these two, strongly agree and agree. 12 plus 3, 15 would be the new 15 would be the your new value. 30 would remain the same. 45 plus 10 disagree plus strongly disagree would be 55. This would be a new value. This is one way of conversion of data. Or you can go with this kind of data conversion as well. For example, you want to check whether corporate social responsibility is affecting the company's performance or not. And corporate social responsibility might have 3 or 4 indicators. You might club them together and make CSR as one indicator only. For example, you might check you might check their social, economic, environment reporting separately, but you feel like that they are not giving very good results, or you might see that they are not as valuable as the total CSR. So you might take summative score of 1, 2, 3, or n number of variables. That is also a kind of data transformation. Index numbers. Score or observation recalibrated to indicate how it relates to a base number. For example, consumer price index. Like this, you can calculate it. Index on the basis of household size or anything can be calculated like this way. Calculating rank order. How would you calculate rank order? On the basis of ordinal data, brand preferences, right? For example, ranking of dream destination out of 4 places. 4 persons have ranked their dream destination like this, right? Or you might take this preference like this: first, second, third, and fourth of all the destinations, right? And then you can collab them and make a new rank order. Then tables, banner heads for columns and stud heads for rows. For example, like this. You can show, you can tabulate the whole data like this, like all consumers, experimented, percentage units, and their index number, right? Known high school grads, again the same units, then for high school grads, and then for those who attended or who are graduated, right? So this way you can formulate a index number table. Computer programs for analysis are the very most widely used software is SPSS, Statistical Package for Social Sciences. Then SAS is there, SysStat is there, Minitab, Microsoft Excel, and Web Surveyor. These are the most used, you can say, programs for analysis these days. And this would show you output like this. For example, for descriptive analysis, mean, your standard deviation, minimum value for that particular variable, maximum value shown, standard error shown, their sum, the total sum of the values. Like this, you will be getting the table, and you can analyze it then. Interpretation is the most important part of the analysis, the process of making pertinent inferences and drawing conclusions about managerial implications of the variables, how would they be applicable in your company now, and concerning the meaning and implications of a research investigation. Whatever objectives you have mentioned earlier, as per them, you will be justifying them, you will be interpreting them. So this was all about descriptive analysis, and it's the most easy part of analysis. You will be describing the whole data, right? And you will be discussing further parts of analysis. This is most of the projects would include either of descriptive analysis for sure. So you should, this is the most important part of data analysis. Let us discuss some true false. The researcher examining descriptive statistics for any particular variable is using univariate statistics. Yes, it happens. Whatever kind of project you are using, you will be definitely using univariate statistics. That's true. Second is the type of measurement scale used in the research study determines the possible statistical test that can be used appropriately with the resulting data. Yes, true. Third is all statistics that are appropriate to use for higher order scales, ratio scales are the highest, are also appropriate to use with lower order scales, nominal scales, which are the lowest. Is it? No, not at all possible. But otherwise, it would be possible. Those scales, lower order scales, no, the kind of statistics you will be using for nominal scales are actually readily usable for ratio scales, but otherwise it is not possible. So it is false. Tabulation refers to the orderly arrangement of data in a table or other summary format. Is it? Yes, it is. So true. Cross tabulation allows the inspection and comparison of differences among groups based on nominal or ordinal categories. Is it? Yes, true. Sixth is a contingency table is a data matrix that displays the frequency of some combination of possible responses to multiple variables. Yes, it's true. Seventh is a 3x4 table represents a contingency table with 12 variables. Yes, 3 into 4, 12. Yes, true. Some self-assessment questions. Number 1, what are descriptive statistics and why are they used in business research? Descriptive statistics is the elementary transformation of data in a way that describes the basic characteristics such as central tendency, mean, median, mode, distribution, and variability of the data. Averages, medians, modes, variance, range, and standard deviation are the typical descriptive statistics. And these are the most widely used in business because we use most of the things to summarize responses from large number of respondents. Explain what a contingency table is and discuss how it is useful in business research. Contingency table is a basically data matrix that displays the frequency of some combination of possible response to multiple variables. Two-way contingency variables, meaning they involve two less than interval variables and are used most often, right? Using these values, we can draw more specific conclusions rather than just simply mean, median, and mode. That is why these are used most in the business research. Explain what an index number is and how it is computed. What level of measurement is required to compute index numbers? Index numbers represent simple data transformations that allow researchers to track a variable's value over time and compare a variable with other variables. To calculate an index number, as a base number is first selected, then index numbers are computed by dividing the score of each category by the base number and multiplying by 100. If the data are time related, a base year is chosen and the index numbers are computed by dividing each year's activity by the base year activity and multiplying it again it by 100. Index number require basically ratio measurement scales. It would not be done with nominal or ordinal scale. Last is list different computer software products designed for descriptive statistical analysis. We just discussed in our last slide. You can mention the name of variables. There are so many SPSS, SAS, Minitab, so many variables are there. You can mention them, right? That's it. In our next presentation, we'll be discussing graphic aids to the analysis. This was just mean, median, and mode and the tabulation of the data, right? If we have presented the data in the form of mean, median, mode, and the table format, even after that, we can go with line graphs, charts, bar graphs. So many things are there, right? And that makes the analysis more beautiful because it is always said the picture says more than 100 words, right? So we'll be discussing graphic aids to the analysis in our next video. Thank you.